Hey everybody. In the last video, we used the t-test and the calculator to find a p-value for an experiment that has to do with the average weight of a species of turtle on an island. So let's figure out what's happening inside this menu. How does it actually get that probability? So I'm going to kind of sketch out something that is parallel to what we did with a proportion, and then we'll see why we can't do it quite that same way. So what we did with proportions is we said, okay, what is our null assumption? Our null assumption is that the average turtle weight is 310 pounds. So if that were true, and we took a sample of 40 turtles and got their average weight, sometimes it would be a little more, and sometimes it would be a little bit less. And so the distribution that's centered at our null assumption shows us what are all of the outcomes we might expect to see if we sampled 40 turtles over and over and over again and find their average weights. So all of these different outcomes might be expected. And what we want to do is we want to know, all right, our actual experiment was here. Let's say this is X bar. This is 300 pounds. So 300 pounds is a little less than 310, so we'd want to know what was the probability. So assuming 310 is correct, what's the probability we would have seen that just by chance? But remember, it's a two-tailed test because we weren't expecting it to go in the smaller direction. It might have gone in the larger direction. So we would also want to see, would we have been surprised to see a result that was that far away from our assumption in the large direction? And how probable would that have been? So we need to actually find both of those. So on the front side, we used normal PDF to find those areas. But this is not the normal curve. This is a t-distribution. So it would be nice if you could do something like this. It would be nice if we had t-CDF where you could give it the low bound and the high bound and the mean and the standard deviation. Because that's the way normal normal CDF works. Unfortunately, this is not the way t-CDF works on your calculator. You can't tell it where your curve is going to be centered. You can't give it a standard deviation. Instead, you give it a different number that controls what its spread is. So we can't quite apply the same approach. So here's what we're going to do instead. If you look at the actual t-CDF menu, t-CDF lets you name three things: a lower bound for an area, an upper bound for an area, and then DF is degrees of freedom, which is related to the spread. And the degrees of freedom is defined as sample size minus 1. So notice this didn't tell us where is the curve centered, and that's because the t-CDF assumes your t-distribution is always centered at 0. So this is a t-distribution, and usually you have a subscript that tells it the degrees of freedom. So here our degrees of freedom is 39. But this is very much like a standard normal distribution. So our X bar was 300 pounds. There's some particular t-value that works like a z-score where these areas are the same. So it's sort of like I can convert my 300 pounds into a t-score that falls in the same position in this curve as my X bar fell in this curve. And so that's the upper bound that we want to be using to find what's that area. So how do you find your t-value? Well, one thing you could do is you could run your t-test, and it told us what the t-value is right here. But the t-score is exactly like a z-score. If you remember the idea of a z-score, we want to find the number of standard deviations a particular value is away from the mean. Up here. So how many standard deviations is 300 away from 310? So we could say 300 is our particular value. If I subtract 310, that tells me what's the distance between them. You might notice that this is a negative number because it's a signed distance. So negative 10 means that I am 10 pounds below the average. But the problem is I don't want to measure this distance from the center in terms of pounds. I want to convert it to units of standard deviations. So how many standard deviations is a 10-pound difference? So I have to divide by the size of a standard deviation to convert to units of standard deviations. Okay, what's the size of the standard deviation? That's just the equation for standard error. So what was standard error? For means, the standard error is calculated this way. It's the population standard deviation over root n. The problem is we don't know what the population standard deviation is, and so we're going to approximate it by using our sample standard deviation. And n in our case was 40. And so our sample standard deviation in this case was 18.5 over root 40. Okay, so this is our standard error that we can plug in there. As soon as we had to approximate the population standard deviation, now we're not allowed to use the normal distribution anymore. Now we're using a t-distribution. So I mentioned in the first video why that's important. It's this moment right here that causes us to need to use the t-distribution. Okay, so if I do this calculation, 300 minus 310 divided by whatever this is, I get a t-score of negative 3.419. And that's what I am going to, okay, it turns out I can't talk and write at the same time. Okay, so my lower bound is going to be negative infinity, which we'll represent as a large negative number. The upper bound is negative 3.419. So you can see like lower is here, upper is here. And then the degrees of freedom, which describes the spread here, is 39. Okay, so you can hit paste, and then that's going to give you the same p-value that we got over here. So it should give you, oh, not quite actually, sorry. That's going to give us just the p-value for this left tail. So it should give us half of this number. Then I would need to multiply it by 2 to cover the other half. So 2 times the p-value given there should be 0.0015. And that's how you could get the same information. Okay, why in the world would you do all this work? It's not really that much work. There's a lot of writing, but I spent a lot of it explaining why we can't do it this way. So really all you're doing is you find a t-score using the z-score equation, because it's really the same thing. And then you plug it in, you find the area. If it's a two-sided test, you double it. So it's not really that many steps. But why would you do them when you could just do this over here? Well, indeed, if you're in an FRQ, this is a great way to do it. But you need to understand what is a t-score. How does it play a role in the p-value? Because they're gonna have multiple choice questions specifically asking you about that. For example, they might say, what's the probability that a t-score is going to be larger than negative 1.5? And you would have to understand, how do I use the TCDF function to figure out the answer there? So both sides of this are important to understand. All right, I hope that this was helpful.